So for 6A, we're going to start with all this vocab. First off, X-Intercepts. We're looking at where they cross the X-axis. You could either write your answers as some number comma 0 or just write the numbers listed. Y-Intercept, we're not going to cover, but just for SAT reasons, you're either looking for a point on the y-axis or you could just list it. Local maximum is sort of a newer vocab word. A maximum is a turning point, but maximums are where some sort of hump is in the graph and you're looking at the peak. But a local maximum should be some sort of point, x comma y. A local maximum is some sort of point, x comma y. That's how our answers will be written. A minimum is some sort of valley, and again, it's going to be a point for our answer. In the directions, it's going to say, identify what turning points are local maxes, and identify what turning points are local minimums. So turning points will become specifically local maxes or local mins. Degree. So highest degree. This is a vocab word from last semester that you will again be tested on this semester for different reasons. Highest exponent. When we look at the graph, we're going to find the number of turning points, and the degree is going to be found as the number of turning points plus 1. The types we talked about last year started with linear, if you had a degree of 1, quadratic, if you had a degree of 2, cubic, if you had a degree of 3, quartic, if you had a degree of 4, quintic, if you have a degree of 5. So on your test, not only are you going to have to identify, well, what's the degree, you're also going to tell me the type again. For end behavior, we either said starts up or starts down. Ends up or down. This recognition of how it starts, how it stops, will help us just keep this end behavior in mind. Next year, if you go into trig pre-calc, you're going to learn the new notation for all of this. So I want to keep this still semi-fresh of identifying end behavior, starting up, ending up. So in the first graph, we already identified what the X-intercepts were. From the warm-up, we said -2 and 1. Now we're going to determine, okay, what's a local max, what's a local min. So the local maximum is at the point -1, 1. That's a peak. And the local minimum, we're looking at 1, 0. Notice how I'm putting these answers in parentheses because maxes and mins are points. Again, you count the number of turning points, add 1, degree is 3. So the type is going to be cubic. End behavior, you start reading the graph and recognize, okay, this starts down and ends up. This next one, notice how the indices are very large. So you're going to maybe get more estimates on the X-intercepts, maxes, mins. So X-intercepts, -5, 2.5, 0. So the local max is about -365. So that valley, 1.5, -19. So now we're going to identify the degree, count the number of turning points, add 1. So again, we've got a peak, we've got a valley, add 1, we're looking at 3. Again, the type is cubic. End behavior is similar. We're starting down, we're ending up. We've got X-intercepts that aren't so perfect. These are going to be more guesstimates. This is more like your test. X-intercepts, okay, -3/4, maybe a 1, and then 2 3/4. You could either write them as fractions or decimals. Local max is looking more clear. 0, 2. Local min may be a little bit more clear. 2, negative 2. And to figure out the degree, now this one again is a 3, but they're not all going to be 3s. And behavior also won't always be starting down, end up. So like in the next example. So negative 1.5 is a decent guess. Not exactly 0, but not 1. So maybe 1/4, 0.1, 0.2. Those are acceptable. And the next one, not 1, not 2, but a little bit over. So maybe 1.1, 2.2, something like that. But we've got 4. Local minimum. So local maximum, 1/6. Local minimum, this is an example where we have 2 of them. So negative 1 and negative 10. And so here's where guesstimating is okay. As long as you didn't put, oh, it's not negative 2.5. We're on the positive realm. So as long as you didn't put 2 or 3, and as long as you didn't put negative 2 or negative 3, because they're not exact, I'm going to be okay. But this is the difference between the word local and the word global. If I wanted a global minimum, then it's just negative 1, negative 10, because that's the lowest point. But because we're doing local, we're going to list them all. So the degree, you count the turning points and add 1. We're looking at 4 if you haven't written it down already. So the word for the type that goes along with 4 is quartic. And then end behavior, start up, end up. All right, homework. You already have it on your paper, but I want you to include in the directions end behavior, degree, type of function, like what we were doing today. So all the pieces that we listed for these problems, I also want on your homework.